Work out the following integral from 0 to 3 over 2 of the square root of 9 minus x squared dx. Again, we're going to use a trigonometric substitution. We will change the limits, so therefore we don't actually have to substitute back. So we let x equal 3 sine u. Now it's 3 sine u because when I square that, that will become, both those will become 9, and then I can factorize out the 9. So dx du will be 3 cos u. So dx will be 3 cos u du. When x is equal to 0, then we've got 3 sine u is equal to 0, therefore sine u is equal to 0, which means u is equal to 0. And when x is equal to 3 over 2, we're going to have 3 sine u is equal to 3 over 2, and that will give that sine u is equal to a half. And then sine to the minus 1 over half is pi over 6, 30 degrees. But we need to use radians with calculus. So this now integral now becomes, changing the limits will go from 0 to pi over 6 of the square root of 9 minus 3 sine u all squared, which is 9 squared u, times dx, which is 3 cos u du. Right, 9 can come out as a common factor. When you take it out of the square root sign, it will become 3, but combined with that 3, it again becomes 9. So we get the square root of 1 minus sine squared u cos u du. That becomes, now 1 minus sine x is cos squared u, so here I can now write this as cos, let's get the notation correct there. As I used x, I'll put x here. Okay, but here we would replace this with cos squared u, cos u du. Okay, writing that out again here. Right, the square, if you square root it and square something, you end up with cos, and then cos u times cos u becomes cos squared u du. Right, there's a special way of integrating sine and cos squared. You use the double angle formula for cos 2a is 2 cos squared a minus 1. Rearranging that for cos squared a, you get a half of 1 plus cos 2a. You're going to take that half out of the integral sign, so it becomes 9 over 2, the integral from 0 to pi by 6 of 1 plus cos 2u du. So that's 9 over 2. Integrate 1, you get u. Integrate cos 2u. Well, we know that d dx of sine 2u is 2 cos 2u. Therefore, I need to compensate by putting a half in front in order to get what I want up here. So it's a half sine tu. Now we need to put in the limits. So we got 9 over 2, pi over 6, plus a half of sine of 2 pi by 6, so that's pi by 3. So it gives minus 0. Now be careful when you put 0 into an integral sign here. Don't always assume that it will be equal to 0. So that will be 9 over 2, pi by 6, plus a half times root 3 over 2. Now it's a common factor of 2, so we'll now have 9 over 4, pi by 3, plus root 3 over 2. Okay, so this has been a video to show you how to do a definite integral using a trig identity as the substitution, or using a trig substitution. I hope you understood, and I thank you very much for watching.